Hello everyone, welcome to Mindspan Education. Let's suppose if you have two random variable x, and this is a standard normal random variable. So this is how we can denote, and since it is a standard normal random variable, it will have the mean 0 and the variance 1. And similarly, let's suppose if you have another random variable y, and it is also the standard normal random variable, so it will also have the mean 0 and the variance 1. And if I told you that these two random variables are independent, then what will be their joint PDF? So if we have to denote this joint PDF, this is how we can denote the joint PDF of these two random variable. And since these two random variables x and y are independent, that means we can write this joint PDF as the product of their individual PDFs, right? And if you recall, what's the PDF formula for the standard normal random variable? So for this random variable, since we have the variance 1, so here it will have 1 divided by 2 pi e to the power x is minus of x square divided by 2, right? This is the joint PDF of this random variable x. And what will be the joint PDF of this random variable y? It will be again 1 divided by root over 2 pi e to the power minus y square divided by 2, right? And if you try to solve it further, this you can take it as, so it will be 1 divided by 2 pi e to the power minus x square plus y square 1 divided by 2. So this is what you will get, right? And now if you try to plot this joint PDF, so this is the constant term, right? And this is negative exponential. So it will have the maximum value when x and y both are 0. For x is equal to 0, y is equal to 0, you will have the maximum value of this joint PDF, right? And now if you take x square plus y square is equal to 1, right? So that would be nothing but a equation of a circle, right? Corresponding to this x square, that means on this circle, if you look at the PDF value, joint PDF value, that would be constant, right? Now if you take some other x square plus y square is equals to 4, maybe this circle, right? So for this value, that is x square plus y square is equals to 4, that means it represents the circle, right? And if you look at the PDF value, the joint PDF value for on this circle, then it will be again constant, right? So what these represents, the circle represents, is the contour of this plot. So if you look at the overall plot, this is how it will look like. So this is the joint PDF, and it will be a bell shaped within this two-dimensional space, and this is the joint PDF, right? So at x is equal to 0 and y is equal to 0, so you can see here y is equal to 0, this one, and x is equal to 0, you will have the maximum value, right? As you go away from both the side, right, the value of the joint PDF will decrease, right? And this is the contour plot. So when this contour plot is helpful, so when we want to represent any 3D plot in 2D, then what we draw is the contour plot, right? So if you look at this yellow region, right, so this yellow region is represented here in this contour plot. So if you are within this region inside this circle, what it represents, this yellow and this yellow, is that the joint PDF will be maximum, and if you go away from this, the value of the joint PDF will decrease, right? So when this contour plot is helpful, so even since it is in 2D, so we are able to easily draw this contour plot, right? So by looking at this contour plot, even I have not given, and if I have said that this is a joint PDF of this standard random variable x and y, where these are the independent random variable, then by looking at this contour plot and by looking at the colors density, I would be able to say that the joint PDF is maximum as we go towards the center, and as we go away from the center, the joint the value of the joint PDF will decrease, right? So this was the case when this random variable x and y was standard normal. That means it was having the mean 0 and the standard deviation 1. What happens to the case when you have just the normal random variable? That means it will have any mean or any variance. Then how the plot or the contour will look like of a joint PDF? Let's look at that first of all. So let's suppose if you have now the any general joint PDF, any general joint random normal random variable, and those are independent. So what we are looking is the independent normals. So we have this random variable, normal random variable x, and it is uniform normal with the, let's say, mu x mean and sigma x variance, sigma square x variance, and we have another random variable that is again a normal random variable with mean mu x and sigma square y is the variance, and these are two independent random variable. And if we have to write the joint PDF of these two random variable, we can simply multiply their individual PDF, then we will have the joint PDF, right? So here we will have 1 divided by 2 pi sigma x sigma y exponential minus x minus mu whole square divided by sigma 2 sigma x square, and minus y minus mu y whole square divided by 2 sigma square. Right, so this is what we will get, right? So you just need to write the individual PDF of this x and y and just multiply that. This is what you will get, right? And if you look at the plot of this joint PDF, so now look at this thing. So this is nothing but the equation of ellipse, right? And it will have the center at mu x and mu y. So these means will decide that where the center of ellipse will be there, and this variance will decide what will be the length of the major axis and the minor axis, right? So if we have to draw the contour of this joint PDF, let me first of all show you that how the joint PDF plot and its contour will look. So this is how the joint PDF will look like, right? And again it will have the maximum at x is equals to mu and y is equals to mu. So let me draw it somewhere. So if this is x-axis and this is y-axis, now the center of the joint PDF will be shifted somewhere at x is equals to mu and y is equals to mu y, somewhere here, right? And if we assume that this sigma x is greater than the sigma y, so we will have this kind of ellipse, right? And for each ellipse, so for each ellipse, the height of the joint PDF will be constant, right? And this is what you can see here in the contour plot, right? And if this sigma y is greater than sigma x, then you would have kind of the contour that would look like this, right? And the one more point to note here is that the axis of the ellipse will be parallel to the original axis, right? So the axis of this ellipse will be the original to how the original axis was there, so it will be parallel to. So basically you can understand this from the equation that the complete bell curve will get shifted to the mean position of the random variable x and y, and these sigma will tell you that it will be tilted towards x-axis or it will be tilted towards y-axis. So that is it, right? So the joint PDF of two independent normal has a shape of bell. The center of the bell is determined by the means of these random variables. Furthermore, the bell is stretched in x and y direction by the amount that is determined by the variance of this random variable x and y, right? And one more point, if you would have some relation or some dependence between these random variable, then the axis of this ellipse would not be the parallel to the original axis, right? You would have ellipse of maybe of this kind. So in that case, the axis of the ellipse will not be the parallel to the original axis. Okay, that is all in this video. In next video we will be looking few more points about this continuous random variable and this discrete random variable combinedly. So there are few things to look at that we will look in next video. Thank you so much.